In this example, we want to evaluate the integral of x over square root x minus 1 dx. In the denominator here, we have a composition of two functions, the square root of x minus 1. And so this suggests that we might try to use a substitution where u is the inside function of that composition, x minus 1. So if we try that, then we can differentiate to get that du is going to be 1 times dx, or just dx. And at this point, we would typically substitute these values into our integral, and we would hope that everything is going to be in terms of u so that we can find an antiderivative and proceed with the integration. Unfortunately, in this particular case, there is an x in the numerator that is not accounted for in this substitution. And so in order to use substitution here, we need to somehow replace that x in the numerator with a quantity in terms of u. Now, in order to do that, we're going to revisit our defining equation for u, which was that u is x minus 1. From this, we could solve this equation for x by adding 1 to both sides. And so rewriting that equation, we see that x is going to be u plus 1. And so we can now replace the x minus 1 in the denominator with u. We can replace the x in the numerator with u plus 1, and we can replace the dx with du. So we're using all three of our values here on the left-hand side. And so if we make those substitutions, we have the integral of u plus 1 divided by the square root of u times du. And now everything here is in terms of u, and so we can go about and integrate this in terms of u, and then eventually substituting back to get the integral in terms of x. So in order to compute this integral, probably the easiest way is to do some algebra here first. We're going to split up this function across the sum in the numerator. So we're going to have u over the square root of u plus 1 over the square root u, all times du, of course. And here, u over the square root of u is going to be u to the 1/2 power. And 1 over square root u is going to be u to the negative 1/2 power. Again, that's using that the square root of u is u to the 1/2 in both cases, and combining the exponents. And so what we have to do now is compute this integral, which we can do using the power rule. So here we're going to use the power rule on each term of our integrand. The antiderivative of u to the 1/2 will be 2/3 u to the 3/2. And the antiderivative of u to the negative 1/2 will be 2u to the 1/2. Of course, we want to add our arbitrary constant c. At this point, we can go ahead and substitute in our value for u, which is x minus 1. So we have 2/3 x minus 1 to the 3/2 power, plus 2 times x minus 1 to the 1/2 power, plus c. And this would actually be a perfectly fine answer. It is a function in terms of x, and the derivative is going to be the value in our original integral, the x over square root of x minus 1. But we could actually simplify this a little bit more just to make it a little bit cleaner. So if we wanted to do that, what we could do is factor out the x minus 1 to the 1/2 power. And so if we factored out the x minus 1 to the 1/2 power, what we would have left is 2/3 times x minus 1 to the first power plus 2. And all of that, again, plus our arbitrary constant c. So this then, in the brackets, we can distribute this out, and we see this is going to be 2/3 x minus 2/3 plus 2, right? All plus our constant c. And so our sort of most simplified version will end up being x minus 1 to the 1/2 times 2/3 x plus 4/3 plus c.